everyone, welcome to this episode of CQLabs. My name is Matusz and today we will be talking about the DNS and DNSSEC. We will have a look at cache poisoning attacks and how you can prevent them with the DNSSEC in your network. In the second part we will have a look at the DNS amplification attacks, how adversary can use DNSSEC in order to increase the impact of those attacks, and then we will finish with the response rate limiting and how you can prevent amplification attack with that. So let's start.
Okay guys, so before we start, let me do a quick recap on the DNS terminology. I'm not going to cover everything, but you can easily Google these things. I just want to mention a few important definitions which we'll be using during today's session. So the first thing which I want to talk about is the DNS server. DNS server is basically server responsible for storing and serving DNS data. Second thing is DNS resolver. That's a piece of software responsible for taking a request from the client and forwarding it to the DNS server. Usually you have a system DNS resolver which is part of your operating system. So that's what we're mostly referring to. Third thing is DNS client. DNS client is an application, like for example your web browser, where the request originated, or any other application basically which have to communicate over the network. Another thing which we'll be talking about or we'll be using today would be the TLD or top level domain. That's for example .com or .org. Now there are a few types of DNS servers or few categories. We can split them too. First would be the root DNS server. This is the server which will hold the IP addresses of old authoritative servers for TLDs. So if you ask DNS server what was the IP of closest authoritative server of .com or .org, that's where you get your answer. That's where all the queries start if DNS server doesn't have any clue where to look for. Second category is authoritative DNS server. This basically means that the server is containing and is responsible and is managing the information about the given domain. So for example, you can have authoritative server for .com or any other domain, your own company domain. Third category, which we'll be talking about today, is caching DNS server. This is basically a DNS server which have a capability to store the request. So for example, when one user will ask it to resolve the DNS query, he will remember that information for a certain period of time. So when the second user will come with the same question, it just get the answer from its cache. There is no need for the caching DNS server to contact additional DNS servers if the information is stored in its cache. Just maybe one quick note: when you have the reply from caching DNS server, this is called a non-authoritative response, and it's because the caching DNS servers are not responsible, are not authoritative for the domains they are usually replying to. The last one which I want to mention is the recursive DNS server. So this is basically a server which is configured to accept recursive queries. So in DNS we have two types of queries, or I want to tell you about two types of queries. First one will be recursive query. This basically means that the resolver will ask DNS server to resolve a query, and the server will do all the work. So it will contact additional DNS servers. It will keep trying up to the point that he will either receive the IP address or it will reply with the message that a certain domain couldn't be found. Second type is iterative query. This is when DNS server will only check its own cache and will not do the full resolution on its side. So for example, if you send query to the server and additional DNS server will reply back to him that I do not know IP address for this domain, but this server could, then the server which is not recursive will just reply to you that he didn't find the answer and this is the next server you should look. So basically the difference is that either resolver is doing all the work and replying and sending the request and reaching to DNS servers one by one, or in case of recursive DNS server, the first DNS server is doing that and the reply you will get as a resolver is always finite. So let's imagine a client, for example, web browser, will issue a DNS query for my.example.com. System resolver in your operating system will accept the query and forward it to the recursive server. Recursive server will either reply with the cache data or contact the root server in case it doesn't know the IP address of .com. So the root server will reply with authoritative server for the requested TLD, in our case .com. Then authoritative server.com will reply with authoritative server for .example, and then finally .example will reply with the IP address of my.example.com. Then recursive server will forward the answer to the system resolver. So this is now in our operating system, and system resolver will forward the answer to the client. Important thing to remember or to understand in here is that most servers will have their own cache. So it's likely that the recursive server will skip a few points here and wouldn't ask for the IP address of .com or .example, and he would probably know it. So the process will be much shorter in the real life. I just wanted to show you how the full scenario looks like. So as we saw, in the normal DNS resolution, there are many hops from the initiator, which is our computer, to the DNS server, which actually knows the answer. And on the way, the message is, as it is contacting a multiple DNS server, there is a chance that the answer will be in one of the DNS server's cache. So this brings me to the first attack, which we'll be talking about, and it's called DNS cache poisoning. And what is actually happening in here is that the attacker, by injecting the malicious or invalid responses to the DNS traffic, may be able to reply to the caching DNS server with an invalid or malicious information. As a result, the DNS server will keep serving this malicious reply to all the clients up to the point that TTL, or time to live, of that entry will last. So let me quickly bring you to our demo infrastructure. Okay, so to demonstrate the cache poisoning attack, we will be using 4 machines. You can see 2 of them at the moment. So first one is our DC1, which has the IP address of 1. So this is domain controller, also DNS server, and we are using this DNS server as authoritative for our dangerzone.com domain. Okay, second machine, which you can see, is our DNS1. So this is DNS server, which is .2, and this is DNS server which will be used to basically we'll be using as a caching recursive DNS server in our demonstration. So it will accept the request from the Windows 10 machine and forward them to our authoritative DNS server, also being domain controller. Third machine, which we will be using today, is a Windows 10 machine. So this is our client. So this is where the messages will be originated. So host name. So this is client 1, and IP address of this machine is .3. And the last machine which we will be using today would be our Kali Linux. And the IP address of this machine is .4. So we don't need Kali at the moment. What I want to show you firstly is how the typical DNS request would look like in our environment. So let me start capturing with Wireshark. Then let me clear the cache of our DNS server. And now let me request test danger zone.1 from our Windows 10 machine. As you can see, we will be asking the DNS one. So let me send it. Okay, we got our reply, which is .1. Now let's stop the capturing. Let's make it bigger, so it'll be easier for you to see. This is our DNS server, and what happened, what we are looking for, is that our machine, which is .3, sent the DNS request for the test danger zone to our DNS server, which is .2. .2 forwarded the request to the .1, which is our domain controller. Domain controller replied with the IP address, which is 01, and send the reply to our DNS server, and then finally our DNS server in here .2 replied to .3, which is our client, saying that the IP address for test.dangerzone.com, as you requested, is .1. Okay, so now let's have a look at how DNS cache poisoning works. We'll be using as the attacker's machine, we'll be using Kali, and we will be using Ethercap. This attack will have two phases. First will be the ARP poisoning, and second would be DNS cache poisoning. So first thing which you need to do is to start the Ethercap. This will be the tool which we will be using. So first thing you want to do, is to because we will be doing DNS spoofing, we need to change configuration of this file. So it's /etc/ethercap/ether.dns. And in here, for us, I created the entry. So for all requests to test.dangerzone.com, we will spoof the IP address to 10.4. As we saw before, the correct IP address was 10.1, and in this attack, we will be spoofing it to .4. So let's go back to the Ethercap. You need to pick the interface which you want to sniff. So in our case, it's Ethernet 0. We will stop the sniffing. First phase will be the ARP poisoning, as I was mentioning. It's man-in-the-middle attack. So we will be intercepting and changing messages coming from the DNS server to the domain controller, and the other way around. No, actually, first thing we need to choose the targets. We'll go to hosts, host list, and now we will do Control S, or you will click host and you scan for the host again. So we are looking for the 01 and 02. Perfect. So 01 is the domain controller, so that's our target 1, and the 02 is our DNS server, so that's our target 2. Now we can proceed with the ARP poisoning, and last thing which we need to configure or enable is in the plugins, we need to look at for DNS spoof, which is here. So now we have it enabled. We can start sniffing. Right now, let's switch to the DNS server and clear the cache. DNS. Let's clear the cache of it. Okay. Back to the Kali. So we have Kali on the right side, our Windows client on the left side, and we again do the same request as before. And as we can see right now, what we got from the our DNS server is .4. Now if we switch back to the DNS server, have a look at the logs for the test. And here we will see the DNS server thinks the domain controller, which is 01, gave him the IP address of the test.dangerzone.com being 10.0.0.0.4. What happened right now is that this information is cached. So if we go back to the Kali right now, and we will stop DNS spoofing, we will stop man-in-the-middle attack, we can actually turn off the ethercab and pulse the machine. So there is no interference from the Kali at the moment, and we will perform the same query. You see we still have the spoofed record because now the wrong answer is in the cache of the DNS server, this DNS1 which you are requesting it. So if we click here and clear the cache, now the DNS server will again ask the domain controller, and as you can see we have the proper answer. So this is the basic of DNS cache poisoning attacks, and the same thing is happening in the real life, in the real infrastructure. Those entries are valid for the period of TTL, which is time to live, which if you are attacker you could configure for quite long time. So that was the DNS cache poisoning attack. Important thing to understand is that the same thing is happening in the real live environment, in the real infrastructure. Normally what we are currently using it as a 01, so our domain controller, that will be authoritative server for example .com domain. Our 02, so DNS server in our infrastructure, it would be a recursive DNS server, like for example 8888 from Google, and our client will be still our client. So theoretically, if someone could be able to interfere with the cache results in, for example, Google servers, then all the users requesting the same domain will be receiving the fault or malicious answers with the malicious IP address for the period of TTL, or for the period that someone will actually notice that this is not correct. So that being said, let's have a look at the DNSSEC, and let's start with a little bit of theory on how it works. So let me switch to our domain controller machine. And if we switch to the DNS manager, we see that this is our zone, which we're using today, and our DNS server is authoritative for this zone, dangerzone.com. First thing, as we can see right now, in the zone there are no keys, there are just entries. So we have entry for client 1, for the test which we are using, and so on. What DNSSEC is basically doing, I don't want to go to the details, but to give you the brief understanding, is that the authoritative server, which is in here, will sign all its records and then distribute the key to the DNS server on the right side, which we'll show you how to do, and then the DNS server is able to verify the signature on all the records, and therefore make sure that they are not being tampered while they are sent on the network. So for example, if you try to spoof such a record, signature will not be valid, and therefore the DNS server knows that this is not the genuine information from the authoritative server, in our case DC1. So in Windows, if you wanna assign the zone, you can do it with the DNS manager fairly quickly. Just next. I'm using default settings just for the sake of the presentation. And now, as you can see, we have a lot of cryptographic information in here. What is also important is that in C Windows System32/DNS, we have the key set danger zone, and this is something which you need to import to our DNS server. So if we now go to the trust points, as you can see, it's empty. We can do import DNS key and then //dc1 and then DNS key set danger zone, in our case dangerzone.com. Now we see we have the key pairs. So now DNS1 would be able to verify if the answers from DC are actually genuine or if they are spoofed or changed somehow while they are on the network. Let me just remove the DNS key part. So if you run the same request again, as you can see, we are getting the DNS server failure. This is because our spoofed messages from our Kali Linux don't have any signature, and if DNS server is not able to perform validation because of the wrong signature, or the answer doesn't have any signature, therefore server will not even try to attempt to validate the response, and in such scenario DNS server failure message is displayed. So what that was the how you can solve the DNS cache poisoning attacks with the DNSSEC. Next thing I would like to show you is how DNSSEC actually can be used to perform amplification attacks. What are amplification attacks? And we will also quickly talk about the response rate limiting. Let's switch to the domain controller and our Kali machine, as the best way to demonstrate this would be from Linux using dig. And we will be asking for information about our domain danger zone, all of it from 10.0.0.1, which is our domain controller. And so let's just fire it up. And as we can see, this is the length of our request. You can see the response is a bit longer, but it's approximately the same thing. Now, if we add the DNSSEC data into it, we can see that the response to our request is approximately 20 times longer. So this is basic idea behind the amplification attacks, because right now it's very easy, for example, to spoof the IP address in the way that the request would go not to me, so not to the .5 when it originated, but for example to some web server which you want to target with your DDoS attack. And if you control like small botnet, which could be a few tens or maybe even thousands, depending on thousands is not small, but if you control any computers from which you can send such a malicious request, then if you will use some amplification technique like this one, it will basically multiply all the traffic you are sending to those affected DNS servers 20 times, and then reply or answer your questions to the target. To fight this, usually you would use some response rate limiting software. It's basically solution which has two parts. First, we'll detect some patterns in arriving queries, and based on those patterns, then we'll implement some policies. Like, for example, if it see that some IP address is sending a huge amount of the same requests, then, for example, it could limit the rate on at which the responses are sent to that particular IP address, and therefore it would render such attack, as we just saw, useless. Because if you can send such request 1 in 10 seconds, for example, it would be very hard for you to perform a distributed denial of service attack.
Okay, so today we were looking at DNS. You should be able to prevent DNS cache poisoning attacks using DNSSEC, and also DNS amplification attacks using response rate limiting. If you need more information or you are interested in this topic, have a look at CQUREacademy.com. Stay secure, and thank you for watching.